Good day, fellow grade nines. Today we are going to deal with exponents. So let's begin. Okay. Feel free to subscribe to the channel so that every video related to the content, when I post, you can receive a notification instantly. Okay. So like and subscribe. Now we have laws of exponent. The first law that we have is law one, multiplying powers of the same base. So what does this law say? This law means if you have a raised to the m multiplied by a raised to the n, the answer that you will get is a to the power of m plus n. Meaning that when you multiply powers of the same base, you keep the base, one base, then you add your exponents. So we say this is law 1. Okay. Now we are going to deal with examples later on, and you will get to practice more about it. Now, law 2, it says when dividing two powers of the same base, we leave the base and the same and subtract the exponents. Okay, so this one is also straightforward. So if you have a to the power of m divided by a to the power of n, this will mean you keep the base the same, only take one base, then the power of the numerator subtract the power of the denominator. Okay, so this will be your law 2. All right. Okay, let's go and find another one. So this one over here is just an additional one. It's not specified as a law, but you need to know any number. For example, in this case, a to the power of 0 is 1. Even if you take 100 on your calculator, raise it to the exponent of 0, you are going to get a 1. Okay, so any number to the exponent of 0, the answer will be 1. Any number, whether it's a 10, 25, 2.5, any number raised to the 0, you are going to get 1. Okay, no problem. Now, law 3, raising a power to a power. Okay, now what law 3 says, if you have a to the power of m, okay, now you say all, meaning everything, also raised to the power of n, the answer should be m, a to the power of m times n. Okay, so that's the meaning of that law. Now let's check the next one. Law 4, raising a product to a power. If you multiply two numbers and you raise it to the power, what happens? So if we have a times b, so I'm using a dot so that you can know that other books use a dot as a multiplication. So if you have a times b all raised to the n, what does it mean? It simply means you can say a to the n times b to the n. So what we use here, we call a distributive law. You distribute n to b, you also distribute it to a. Okay, now let us proceed. That is law 4. Now I can see they summarized everything. So we have to know again about this one. Add a negative exponent one. Now, if I have a fraction raised to a power, for example, a over b raised to the n, this is equivalent to a raised to the n divided by b raised to the n. Okay, And again, for additional purposes, this is like 8 raised to the 0. If you have 1 over a exponent m, this is equivalent to a raised to the negative of m. And you can also reverse it. Okay, so this is reversible. You need to know this. Okay, now I'm going to make an example again based on the very same concept. If you have a raised to the negative n over a raised to the negative m, this is equivalent to make the exponent positive. Okay, to make the exponent positive, you need to change its location like that. So a raised to the n will come down as a denominator, then it becomes positive. A raised to the m, negative m, will go up to have a positive exponent. Okay, so that is the concept about laws of exponents. Okay, guys, um, we are going to deal with some few examples, and I'm going to need you to remember these ones. You can take a picture if you're using a PC where you are, and uh, you can reference these laws when you deal with examples. Okay, there is no need for you to memorize them as this is law 3, law 4. What matters is the application. Okay, the numbers that this is law 6, law 5, it's not necessary for you to know. Okay, good. So now let's take a few examples and see what we are going to have. Okay, no, not this one. Let's check this. Yes. So in this one, I'm going to focus on number 10, number 11, number 12. Let me proceed. Okay. Uh, Number 10. So you guys can also take a picture of these questions. Then, but I'm also going to write them down. Okay. So now the first question that we're going to deal with is negative 10. Negative 10x y raised to the third, or divide by negative 8 x cubed times y. Okay, now it's like that. All right, now the first step is to simplify your numbers. Simplify your numbers. Okay, so all those two numbers are divisible by negative 2. So to write them in a simplest form, we are going to have a positive 5 divided by 4 after dividing each number by negative 2. So negative 10 divided by negative 2, you get a 5. Negative 8 divided by negative 2, you get a 4. Now I have x. Okay, so you take the ones with the common base, right? X in the numerator, it has a power of 1. You take the numerator minus the power of the denominator. So x1, this is 1 here, minus 3 in the denominator. Then times y. Y of the numerator is 3. It's raised to the power of 3 minus the power of the denominator, which is 1. Okay, now let us simplify those exponents. You have x to the negative exponent times y squared. But now you are not allowed to leave your answers with a negative exponent. So how are you going to deal with this? To write this number in a proper way, it's going to be 5y squared divided by 4x squared. Now notice the change in the power of 2, in the power of x. I mean, it was positive, but when I made it a denominator, I mean it was negative. When I made it a denominator, it became a positive 2. Okay, please take note of that. All right. The next one will be, let me erase. So remember, guys, try to pause the video, do the question by yourself. Then when you're done, unpause the video, check for the solution. Okay, that's the best way to learn, guys. That's the best way to learn. You have a negative 2 x raised to the power of 5, y raised to the power of 6, all squared over 4x y raised to the 4, all raised to the power of 3. Okay, so remember, guys, I said when you see numbers like this inside parentheses and all of them are raised to the power, you use a distributive law. So these two will distribute to the y, will distribute to the x, and will distribute to the 2 again. So what we are going to have, we are going to have a number that looks like this, negative 2 squared. Now, when you have a negative number, put it inside parentheses, okay, brackets, all right? X to the power of 5 times 2, y times y, exponent 6 times 2. Now, everything is over 4 exponent 3, so that distributive law also applies in your denominator. X exponent, x is an exponent of 1 times 3 multiplied by y exponent of 4 times 3. Okay, so now how will this thing look like? Let us try to simplify the powers now. So a negative 2 squared will become a 4. Now x to the power of 5 times 2 is x to the power of 10 multiplied by y exponent 6 times 2 is 12. Then you have 4 cubed. Now you are not going to change that one into a number because we are dealing with exponent. We want common basis. So in the numerator we have a 4. We keep this one as a 4 cubed so that we can deal with exponents. Alternatively, you could have changed this 4 also into a 2, but then it's fine like this. It's not a problem. Then we have x to the cubed times y to the 12. All right? 4 times 3 is 12. Now, let us deal with exponents. We use that law that says when you divide, you keep the base, subtract the exponent. So 4 exponent 1 minus 3, okay? Then x exponent 10 minus 3 and y multiplied by y exponent 12 minus 12. So we'll have 4 exponent negative 2 times 10, not 10 but x, okay, forgive me for that. X to the power of 7 multiplied by y, 12 minus 12 raised to the 0. So any number raised to the power of 0 is 1. So to simplify this, we are going to have x to the power of 7 divided by 4 squared. Okay. Now the instruction says simplify the following and leave your answer in exponential form. Remember, I said you could have changed this 4 into a 2 instead of changing that one. Okay. So even here, you will need to change this back to a 2 because it says you need to simplify. Now it's not simplified yet. So this will be x to the 7 over 2 to the 4. Why 4? This is 2 squared. So raised to a 2, it becomes that. Now this is your answer in the simplest form. Okay, happy? Okay, now let us do the next one. I hope you guys are happy about this. Okay, let's clean up. So this is one of the easiest topics where you should score marks, guys. I think on your final paper, I'm not so sure, it will be question 5 for grade 9. Okay, good. Let's proceed. Lastly, we will be having -2 a squared times b c cubed. Everything there multiplied by 9. This is 9. A b c squared. Now everything into minus 6a squared b raised to the 0 and c to the power of 7. Okay, now we need to simplify and leave this with exponential form. And remember, the exponents must not be negative. Okay, so when it's like this, I will deal with the numerators first and the denominators first. Then that's when I can do everything together. Now, in the numerator, we take like terms. -2 times 9 is -18. Okay, a squared times a, like what I do, I take the like terms. So a squared times a, so it's common base, right? So what do you do when you have common base? You add the exponent. So we have a squared plus 1 from the other side. So that will give us a 3. Okay, so now we can write it in the form of a. I'm sorry about that. I've been meaning to take black. We can write it in the form of a cubed. Okay, b exponent of 1 plus b exponent of 1. When you multiply, then you add the exponent, it will be squared. Then you have c exponent of 3 and exponent of 2 will give you exponent of 5. Okay, now you are done adding the exponents. You go to the denominator now. When it's like this, I said use the distributive law here on -6a all squared. So -6 squared will be positive 36. Then a will have a squared. Then b to the power of 0 and c to the power of 7. Now, can we simplify this? Yes, of course. Uh, this is half of that. So we are effectively going to have a negative half. All right. Then we have a 3 of the numerator minus 2 of the denominator times b squared minus 0 times c to the 5 minus 7. So what do we have? We have negative 1 over 2 to the a times b squared times c exponent minus 2. Okay, now let us write it in the simplest form. It's negative 1 over 2. So all variables with positive exponents goes to the numerator. It's a b squared over c squared. And that is the simplest form. Remember, 1 is not necessary to write. I'm just showing you where the half went to. So effectively, in your book, you're going to leave it like that. Okay, so that is the final answer. Happy? Okay, guys. I guess now you are growing in the topic of exponents. So I'm going to move up a little bit and introduce a new concept. Okay, good. Now let's get the new one. Okay, so we are effectively going to deal with. Let me remove this one. We are going to deal with these three. Okay, so let's see. We have we have 10 x cubed y over 5 over 5x y squared. Everything raised to the power of 3. Okay, so what effectively we are going to do here, I'm going to rewrite it in a form that you can understand. This actually means 10x cubed y raised to the cubed, then 5x y squared raised to the cubed. Okay, now you can use your distributive law. What is distributive law say? Okay, what you need to do with distributive law, you multiply that into the 3 and into 10. Okay, the same with this one. You multiply it into 2 into the power of x into the power of 5. Okay, now let's proceed with it. So what you are going to have is 10 cubed x to the power of 3 times 3 y to the power of 3 over 5 cubed x cubed y to the power of 2 times 3, okay, which is the same as 10 cubed, okay. 10 cubed, then we have x to the 9 y cubed all over 5 cubed x cubed y to the exponent of 6. So I'm going to perform a little magic here. Okay, I'm going to replace this 10 with 2 and 5. But how can you do that? So it's fine. Let me show you how. Now 10 is the same as 2 times 5. Okay, where I see 10, I'm going to replace by 2 and 5. So here, where I see 10 cubed, I'm going to replace by 2 times 5 all cubed. What Mas rule says you start with 2 times 5, which will give you 10, then raise to the third. So nothing changes. Okay? So now that you understand what I'm about to do, I will erase here and then write it. I will leave it with a red pen so that you can understand it's 2.5, meaning 2 times 5 raised to the third. So this will come there, this will go there. Understand? Can you see what's happening here? Now, after that, I'm going to rub again so that now you can have a proper format that looks like this. 2 third multiplied by 5 to the third. Now, can you see the magic now? Okay, let us proceed. Now, let us deal with exponents. So, even at the bottom, we have something to the power of 2, but it's just 2 exponent of 0. Okay, so 2 cubed multiplied by 5 exponent of 3 minus 5 exponent of 3 in the denominator multiplied by x exponent of 9 in the numerator minus 3 in the denominator multiplied by y exponent 3 in the numerator minus 6 in the denominator. So everything simplified, it's 2 cubed. Now this will amount to a 1. So I will leave it out. This will amount to x exponent 6. This one, it's times y minus 3. Okay, so the simplified version of the answer will be 2 cubed x to the power of 6 all divided by y cubed. Okay, so does it make sense now? Okay, I will proceed to the next question, which is this one here, number 5. Let us see how we deal with number 5. Okay, so I guess you guys are tired. You can pause the video, go drink water. You can take a 10 minutes break, come back and continue. Remember, guys, Mathematics needs a fresh mind. Okay, so I hope you guys are fresh. Okay, let's see. Good. Now let's go to the question. Now in the question we have 2a raised to the third multiplied by 4a squared all over 8 into a minus 3 squared and everything squared. So when you have an equation like this, you deal with whatever you have inside the brackets first. Okay? Now, um, here, can you see that you multiply everything here? Okay? So you'll be having 2 times 4, which is 8. You can also write it with as a number of exponent in a base of 2. That's if you want to be stylish. Okay? But in the denominator, I have an 8 as it is, so I'm going to leave it as an 8. Then a exponent 3 plus 2, which is 5, because I'm multiplying, divided by 8. Now, when I multiply these two, I'm going to have a exponent minus 6. Okay, everything raised to the 2. Now, we can distribute the power of 2 like this. Okay, so we can effectively multiply the 2 there and there. That's in the numerator. And in the denominator, you can take it and multiply there. And you also multiply it to the power of 8 there. Okay, so let us simplify it further and see how that 2 affects. So you're going to have 8 exponent of 2, a exponent of 5 times 2, which is 10, divided by 8 exponent of 2, and a exponent of minus 6 times 2, which is a exponent of minus 12. Okay, now let us deal with the exponent. So we are going to have 8 exponent of 2 minus 2 times a exponent of 10 minus 12. Now this effectively becomes positive. So I'll be having 8 exponent of 0, which will be 1, times a exponent of 22. So the final answer will be a exponent 22. Okay, now this one over here, I will leave it to you as a homework. Follow the steps that we used correctly, you will be able to find the correct answer. Okay, let us go to the next one. So now this is the next exercise. Okay. Um, let me clear the screen. Okay. This time around, I'm going to do multiple problems on one page. Okay. Now, good. Let us proceed. Uh, these are the problems I'm looking at. I will try to do most of them, if not all. Then let's see where we get to. Okay, you can take a screenshot, a picture, pause the video, deal with them, unpause it, and solve it by yourself. I'm fine with any of those. Okay, now the first problem we have is 2 exponent x is equals to 16. Okay, now we have the number 16 and 2. So to solve this, we need to have both sides as the base of 2. So 2 exponent x, which is equals to now 16, as a base of 2 will be 2 raised to the 4. Okay, now when you have same base on either side of the equal sign, you can drop the exponents and equate them. So x will effectively be equals to 4. Okay, now next question, we have 3x, which is equals to 27. So not 2 exponent 7, but 27 as a number. Sorry. Now, can you write 27 as a base of 3? Yeah, of course. So 3x is the same as 3 raised to the power of 3. So x will be equals to 3. Okay. Now, okay, another one, number 12 there. So we have 5 exponent x is equals to 1. Okay, but now how are we going to solve this one? Ask yourself. So you can write 5 exponent x. Remember, we said any number to the power of x, any number to the exponent of 0 is 1. So this can be written as 5 exponent of 0. You can punch 5 exponent 0 in a calculator, it will give you a 1. I chose 5 exponent 0 so that this base can match the base on the left hand side, and effectively x will be equals to 0. Okay, the next one, we have 11 raised to the x. Okay, which equals to 1 to 1. All right, but then I think 121 is a squared number and a square of 11, but I'm not sure, so we are going to verify. Okay, so say 11 multiplied by 11, then we hit equals to, we get 121, so we remove it, so meaning that we can replace 121 by 11 squared. Okay, so 11 to the power of x is equals to 11 squared. Now we have the common base, so x is equals to 2. Make sense? Good. Now we have another one, which is 8 exponent x minus 2 equals to 1. So this can be written as 8 exponent x minus 2, which is equals to 8 exponent 0. Now you have the same base, you can drop the exponents. X minus 2 is equals to 0. Then you can add 2 both sides. Okay, and x will effectively equals to 2. Okay, now let's check number 24. We have 5 times 5 raised to the x minus 5, which is equals to 5. Hmm. How are you going to deal with this one? Now let's see. Easy peasy. So you might think that, wait, do I divide by 5? Well, no and yes. Okay. So in this topic, we assess your ability to deal with exponents. So don't divide by 5 to simplify things. No. So what you need to do, you can see now you multiply two numbers with the same base. So we are going to have 5 exponent x minus 5 plus 1 is equals to 5, and this is exponent 1. So what you can do is to equate the exponents. So it will be x minus 5 plus 1 is minus 4, which is equals to 1. And x will be equals to 1 plus 5, which is 1 plus 4, I mean, which is 5. Okay, I hope you guys are happy. Now, we have another one. It has the similar structure. We have 9 multiplied by 3x, which is equals to 9 squared. Okay, well, you can write 9 in a form of 3, but you cannot write 3 in a form of 9. So what you need to do is turn this into 3 squared times 3 to the power of x, which is equals to 3 squared raised to the 2. Okay, so this is the same as 3x laws of exponent x plus 2. Okay, because you multiply the same base, which is equals to 3 exponent 4. Now the base are the same. What do? You equate your exponents. So which is equals to 4. X is the same as 4 minus 2, which is 2. Okay, uh, let's check the next one. We have 6 exponent x is equals to 1 over 6. Okay, now how do I deal with this one? Easy. Get rid of the fraction and write it in an exponential form. We have 6 exponent is 6, which is equals to 6 exponent negative 1. Okay, now that looks familiar. Yes. What do? You try to drop the exponents because the base are the same. So x will effectively be equals to negative 1. Okay, now let's see if you have mastered that technique. We have 4 raised to the x, which is equals to 1 over 16. So can you see the similarity? Yes, you can. So 4x is the same as 1 over 16 can be written as 4 squared. Then 4 to the power of x can be written as 4 raised to the negative 2. Now you have the same base. You equate the exponent. X is equals to minus 2. Okay, good. Now, how do you deal with this? Okay, so now we have a half like this, all raised to the x is equals to 4. Okay, now how do you deal with this? Make sure you, since you have 2 this side, you make 4 to be in the base of 2. So we are going to have 2 to the exponent of negative 1 all raised to the x, which is equals to 2 to the exponent of 2. Okay, now this looks familiar. You multiply the bases together, you are going to have 2 exponent minus x, which is equals to 2 exponent 2. So negative x is the same as 2 because we dropped the exponents. Now, therefore, if you divide by 1 both sides, negative 1, I mean, you get x is equals to minus 2 because we are looking for x, not negative x. Okay, now can you guys see the similarity there? Okay, so these are the exercises I said we might do. So the ones that I didn't do, take an opportunity to use them as a homework, guys. Okay, so please, please, and please again, take care. Until we meet again, cheers, guys.